is Mr. Smith here. It's Algebra 2, and we are getting ready for a quiz on sections 8.2 to 8.4. The main idea of section 8.2 and 8.3 is about graphing. I am more interested in understanding where the zeros, the vertical asymptotes, and the horizontal asymptotes come from on the graphing piece. There will be on a quiz, out of 10 questions, there will be one that asks you to graph it. Also in section 8.2, we talked about transformations. And you'll notice that there is one problem here that talks and deals with transformations. In section 8.4, we're transitioning now to be able to solve rational equations. And so in 8.4, we're learning the skills like multiplication and division that we're going to need to help us solve rational equations, which comes in section 8.6. So here are 5 questions that all 5 of these, in some various form, will appear on the quiz on section 8.2 to 8.4. So let's get to them. So here, the first thing we're going to do is we need to be able to factor. So this is going to factor into x minus 2, x plus 1. This guy is going to factor into x plus 5, x minus 1. Let's make sure I did this correctly. Yeah, that looks good. Looks good. Here, when we divide two fractions, we flip the second and multiply. In this case, this can factor as 5 times x plus 5, and the bottom is just x minus 2. Now we go through and find things that cancel. So here, this x minus 2, this x minus 2 cancel, this x plus 5, this x plus 5 cancel. And that leaves us with 5 times x plus 1 divided by x minus 1. And we're done. X plus 1 divided by x minus 1 does not cancel out farther. I will tell you that in pre-calculus, you're going to see something like this, where you get like 1 minus x and x minus 1. These will simplify farther. And the way that you have to do this, and this is just a note, this is like a preview of wonderful things to come. The way you have to do this is you have to rewrite it. So let's rewrite the top as negative x plus 1. All I've done is switch the order. And then this is x minus 1. So the bottom stays the same. And now the way that we simplify is we factor out a negative 1 out of the top. So it gives us a negative 1, and then that gives us x minus 1 divided by x minus 1. Okay, so this is something that you're going to be asked to do in pre-calculus. At this level, I don't expect you to be able to do it. I do expect you to be able to see what's going on there, though. Okay. The next question. This is actually more when we dealt with exponents and our rules of exponents. This really doesn't fit in this chapter, I don't think. That's why I didn't stress it. I feel like I've already taught this to you. But in that, it makes for a good review, so let's look at it. So my idea is to rewrite this all as one fraction and combine all of the variables as best we can. So this gives us x to the 5th times x squared is x to the 7th. Y cubed times y to the 1st gives us y to the 4th. And on the bottom, we get 6x cubed y to the 6th. From here, 48 divided by 6 is 8. X to the 7th divided by x cubed is x to the 4th. And y to the 4th divided by y 6th is y squared. Those are just our rules of exponents. And until you're done with mathematics, you do not get to forget those rules of exponents. Okay. On the next set of problems, we want to find the zeros, the vertical asymptotes, and the horizontal asymptotes. And this is exactly the way that I lay this out on the quiz. I just asked for these things. So to find the zeros, we set the numerator equal to 0. This is going to factor into x minus 9, x plus 4. So x equals 9, and x equals negative 4. This is where the graph crosses the x-axis. Okay, all I did is I set the numerator to 0 and I solved. For the vertical asymptote, we set the bottom to 0. So 3x equals 0, therefore x equals 0. That means there's going to be a vertical asymptote there, and that's also the value that's not in the domain, right? Wherever the vertical asymptote is where the domain is not. Okay? So we get a vertical asymptote here. To find the horizontal asymptote, we have to use that chart. There are three options. Either the bigger polynomial will be, and by bigger I mean the bigger degree, so quadratic will be on top. In this case, I have linear on bottom. So the bigger degree on top, smaller degree on bottom. This is the third case where there is no horizontal asymptote. The other two cases, the first one is they're the same degree, linear divided by linear, quadratic divided by a quadratic. And in the first case, we have the smaller degree polynomial on top, the bigger degree polynomial on bottom. Okay, and we'll talk about what to do in that case. Okay. On the second problem, we have zeros. We set the top equal to 0, so x squared minus 9 equals 0, and x equals positive negative 3. To find the vertical asymptote, we set the bottom equal to 0. What kind of equation is this? This is a quadratic, so how many solutions should it have? Quadratic, it should have 2. How many of these solutions are real? Right, because in this chapter, all we're interested in is real solutions. That equation has no real solutions. Right? If you try to solve this, you can either use Pythagorean theorem. You can either use the quadratic formula, or you could subtract the 1, divide by 2, and x squared equals negative 1/2. X squared equals negative 1/2. That none of those solutions are real. Therefore, there is no vertical asymptote. As far as horizontal asymptote goes, this is that second case in the chart. I'm taking a quadratic and I'm dividing it by a quadratic. So the rule says I take the coefficients of the x squared terms and I divide them, and the horizontal asymptote will be the line y equals 1/2. Again, why is it y equals? Because it's a horizontal line. Right? Horizontal lines have the equation y equals. Why is this an equation x equals? Because this is a vertical line. Vertical asymptote is vertical line, so it is x equals. That's just a little nuance you need to pay attention to. Okay. So here are two of our three cases. All right, so the last problem, this is more of an 8-2 problem. By the way, the graphing problem also comes out of 8-2, and it's one of the easiest ones I could give from 8-2. You also have your graphing calculator, so please use that. I would expect that you're going to use that. Okay, so we want to talk about transformations. So this +1 gives us a vertical shift up 1 unit. The -4 gives us a horizontal shift 4 units to the right. When we talk about domain, the domain should be all real numbers except for whatever makes the denominator here 0. So x should not equal 4. So x is a real number. X is a real number such that x does not equal 4. And to find the range, it's probably easiest to consider how the asymptotes are being transformed by this set of transformations. So let me draw the graph. And recall that our asymptotes right now are on the x-axis and the y-axis. And so if I shift the whole thing up by 1 unit, that means our new horizontal asymptote is going to go through here. And remember, our horizontal asymptote was here. Sorry, our vertical asymptote was on the y-axis. And we're going to shift it to the right 4 units. 1, 2, 3, 4. And so that's where our asymptotes are now at. That's how our asymptotes were transformed. So you can see where the vertical asymptote is, that's where the domain is not. And the same is going to be true for the range. Except we're going to look at the other asymptote. So y is a real number such that y does not equal, and where the horizontal asymptote is, there the range is not. So y cannot equal 1. Sorry. If you're curious what this graph should look like, it should do something like that. And again, if you want to get more precise, make an XY table, try to pick some values, and there you are. Okay, so again, your quiz is going to have one graphing, 5 problems that are very similar to the ones that we did here, and one word problem that will resemble the word problems from your homeworks. I would strongly advise you to go back and look through them. At this point, this covers the review that I wanted to go over, at least from these problems. Thanks for your attention. Good luck in your studies. Have a good day.